All right, so you know how much we love getting your suggestions for deep dives.
Oh, yeah.
Well, this time you guys really threw us a curveball.
Yeah.
We're talking about something called A000038.
At first glance,
I know, right?
it looks like some kind of secret code or something
Yeah.
like that.
It's a sequence of numbers, but
Yeah.
not just any sequence. This one is part of something called the OEIS.
The Online Encyclopedia of Integer Sequences.
Yeah, have you ever heard of this?
I have. It's really an incredible resource.
It's like Wikipedia.
Yeah, imagine like a vast digital library where mathematicians
Yeah.
from all over the world can contribute these unique sequences, and it creates this interconnected web of mathematical knowledge.
So is A000000 series area like just one tiny entry in this massive crowdsourced encyclopedia?
Exactly, and it's just one of millions.
Wow.
Each sequence gets its own unique ID number in the OEIS, which
Yeah.
makes it easy to catalog and cross-reference.
Let's get down to it. What does this sequence A00000008 actually look like?
Well, it starts with the number 2, followed by an infinite string of zeros.
Okay.
So 2, 0, 0, and so on.
That's a little underwhelming, honestly.
Yeah,
Is there something more to this than meets the eye?
that's where things get interesting.
Okay.
You see, this seemingly simple sequence has some surprising properties.
Oh.
For starters, the OEIS entry describes A000007 as twice A000007,
Twice A000007.
which is another sequence in the encyclopedia.
Okay, so it's related to another sequence.
Right.
But what does that tell us? Why is that significant?
Well, think of it like this. The OEIS is full of these relationships between sequences. Sometimes a seemingly complex sequence can be generated from a simpler one, or a sequence can be a building block for many others.
Right.
In this case, understanding A000007 could give us some insights into A000008.
We'll have to explore that connection later.
Definitely.
But is there anything else about A000003 that makes it stand out?
Here's a real aha moment.
Okay.
The entry also mentions that A000038 represents the decimal expansion of 15.
Wait, so that string of zeros is just 0.2?
Precisely. It's a simple fraction, but the fact that it could be represented as this infinite sequence of integers is fascinating.
Yeah.
It bridges this world of whole numbers with the world of decimals and fractions.
I'm starting to see why you said this has surprising properties.
Yeah.
So we have a simple sequence that can be expressed as a fraction.
Mhm.
What else can we learn from this A000003 in an entry?
Well, one of the most intriguing things is that even though it looks so simple,
Yeah.
A000038 is actually connected to some pretty complex mathematical concepts.
Like what?
If we look at the comments section
Okay.
on the OEIS page, we see mentions of prime numbers,
Our numbers.
which are like the building blocks of all whole numbers.
That's a surprise. What's the connection there?
It's a bit too deep to dive into right now.
Okay.
But essentially, this seemingly simple sequence with its infinite zeros can help us understand some of the properties and patterns of prime numbers.
Okay, now I'm really curious. The comments hint at these hidden depths. But can we actually calculate any number in the sequence, or is it just an endless list of zeros?
Well, that's where the formula section of the OEIS entry comes in handy.
Okay.
Mathematicians have actually created a formula that allows you to calculate any term in the A00000038 sequence.
Hold on. There's a formula for this.
There is.
What does it look like?
Well, it involves another sequence called A000000,
Okay.
and something called the prime counting function.
Oh, why?
We won't get into the nitty-gritty right now.
Okay.
But the point is, this formula exists, and it allows us to explore this sequence in a deeper way.
So it's like a shortcut.
Exactly.
Instead of having to list out the entire sequence, you can use this formula to find any specific term you want.
Incredibly useful when you're dealing with an infinite sequence.
Yeah. All right, so we've got this formula. We've got a connection to another sequence. What other cool things can we find on A000038's page?
Well, there are sections called Mathematica and Prague,
Mathematica and Prague.
and they actually provide code snippets showing how to generate this sequence using computer programming.
Oh, so even programmers are interested in this sequence.
It goes to show that the OEIS attracts people from all sorts of backgrounds, not just mathematicians.
Right.
It's a real melting pot of anyone who is fascinated by numbers and patterns.
Okay, so we've gone pretty deep on the sequence itself, but you mentioned earlier that each sequence in the OEIS is like a fingerprint for a mathematical concept. What concept does A000038 represent?
That's where we start to see the broader significance of this seemingly simple sequence.
Okay.
The references section of the OEIS entry reveals that it's been cited in research on some pretty diverse topics.
Like what? Give me some examples.
We're talking group theory, which deals with the symmetries of objects.
Okay, that sounds pretty abstract.
It is, but it gets even more interesting. A000038 also pops up in research on machine learning.
Machine learning, so the sequence of 2 and a bunch of zeros is connected to artificial intelligence.
It seems that way. It really highlights how even the most basic mathematical concepts can have unexpected applications in different fields.
This is making me see the OEIS in a whole new light. It's like this giant web connecting different areas of math and even reaching into other fields like computer science.
Absolutely.
But how can we explore these connections further?
Well, there's a cross-ref section on each OEIS page that links to related sequences. For example, for A00000038, we see a connection to A00007395, which deals with something called Euler's totient function.
I have to admit, I have no idea what that is, but I'm guessing it's another thread we could pull on to learn more.
Exactly. And then there's the adjacent sequences section, which simply lists the sequences with ID numbers just before and after A000038.
Oh, so it's literally showing you what's next door in this giant neighborhood of numbers.
It gives you a sense of how everything in the OEIS is interconnected.
You know what? This reminds me of something we talked about, A000038 being connected to A000007 earlier.
Of course.
Remember that. It's time to follow that trail.
Let's do it.
What can you tell me about this A000007?
Its title in the OEIS is the characteristic function of A0 unless N00, in which case AN1.
Okay, I'm going to need you to break that down for me.
Essentially, it's a sequence where every term is 0 except for the very first term, which is 1.
Okay.
So it looks like this 1 0 0 0 0.
And so on. At first glance, it seems even more basic than A00000038.
But remember, even the simplest things can be surprisingly complex.
Right.
What makes A000007 interesting is its role as a fundamental building block.
What do you mean building block?
Well, it shows up in a lot of mathematical formulas and concepts as a way to switch on a specific term or condition.
Okay.
It's like a light switch. It's either on one or off.
Okay. So A000007 acts like a signal highlighting a particular point in a sequence or an equation.
Precisely. And if we remember that A000000 is defined as twice A000007,
yeah,
it means we're basically taking that simple signal, doubling its intensity, and shifting it one position to the right.
That's how we get the 2 at the beginning of A00000007.
Exactly.
It's the one from A000007 doubled and moved over one spot.
Exactly. It's a simple operation, but it creates a whole new sequence with its own unique properties and connections.
This is making me see these sequences in a whole new light. They're not just lists of numbers. They're like encoded messages waiting to be deciphered.
That's a fantastic way to put it. Each sequence in the OEIS tells a story, and often that story intersects with others in unexpected ways.
If we kind of zoom out a bit, what's the takeaway for our listener? Why should they care about the OEIS and these seemingly obscure sequences?
Well, I think the OEIS is a testament to the beauty and interconnectedness of mathematics. It shows that even in something as simple as a sequence of numbers, there's infinite depth and wonder waiting to be discovered.
It's like a reminder that there's always more to learn, even in the things that we think we understand.
Absolutely. And it's not just about the math itself.
Yeah.
The OEIS is a prime example of the power of community and collaboration.
Yeah.
It's this living, growing database built by people from all over the world who share this passion for numbers and patterns.
It's incredible to think about all the volunteers contributing to this vast library of knowledge. So we've got A000008, which you said is twice A000000.
Right.
We've also got this formula that you mentioned uses something called the prime counting function.
Yes.
Can you tell us more about what that is?
Certainly. So the prime counting function is like this special tool that mathematicians use to count how many prime numbers exist up to a certain number.
Okay.
So for instance, there are 4 prime numbers less than 10.
Okay.
2, 3, 5, and 7.
Right.
So the prime counting function gives us a way to calculate that for any number, no matter how large.
So in the formula for A000038, this function helps determine how the sequence behaves based on the distribution of prime numbers.
That's the fascinating part.
Yeah.
It creates this link between this seemingly simple sequence of mostly zeros and the complex world of prime numbers.
Wow, I'm starting to see how deep this rabbit hole goes. We also briefly touched upon Euler's totient function earlier, which is linked to A000038 through the cross-ref section.
Right.
Can you shed some light on that function and its connection to our sequence?
So Euler's totient function, often represented by the Greek letter phi.
No, okay.
There's another interesting concept in number theory, and for any given number, it tells you how many positive integers less than that number are relatively prime to it.
Relatively prime, what does that mean?
It means they share no common divisors other than 1.
Okay.
So, for example, let's take the number 6.
Okay.
The numbers 1 and 5 are relatively prime to 6 because they don't share any divisors other than 1.
Okay.
So the totient function for 6 phi of 6 would be 2.
Okay. I think I'm following. So how does this totient function relate to A00000038?
Well, the link isn't direct.
Okay.
The cross-ref section indicates that there are research papers or mathematical works that discuss both A00000008 and Euler's totient function.
Right.
This suggests there might be some deeper indirect relationship between the two.
Okay.
Perhaps they're both used in similar calculations or they appear in related mathematical theorems. It's like a clue that points towards a potential connection waiting to be explored.
It's like we're uncovering clues in a mathematical mystery novel.
I like that.
Earlier, you mentioned A000038 pops up in research on group theory and machine learning.
Yes.
Those fields seem so different from each other. What's going on there?
That's the beauty of mathematics. It often acts as this bridge between seemingly unrelated disciplines.
Yeah.
In the case of group theory, A000038 might be used to analyze the properties of certain mathematical groups, which are sets of elements with specific operations.
Okay. And what about machine learning? How does a sequence of integers relate to something as complex as artificial intelligence?
Well, it's a bit beyond the scope of our deep dives to explain fully.
Okay.
But certain algorithms in machine learning rely on analyzing sequences and patterns.
Right.
It's possible that researchers have found ways to utilize A000038 or its properties in developing these algorithms. It's a testament to the unexpected ways that seemingly abstract mathematical concepts can find practical applications.
This is all pretty mind-blowing. So we've got this simple sequence A000038 that represents the fraction 15. We've seen it's connected to other sequences, to prime numbers, to Euler's totient function, and even to fields like group theory and machine learning. Where do we go from here? What does this all mean for our listener?
I think the biggest takeaway is that even something as seemingly mundane as a sequence of numbers can be a gateway to a whole universe of fascinating concepts and connections. The OEIS is a treasure trove of such sequences, each with its own story to tell.
So it sounds like you're encouraging our listeners to explore the OEIS for themselves.
Exactly. You never know what mathematical gems you might uncover. Maybe you'll find a sequence that sparks your curiosity, leads you down a fascinating path, or even helps you understand the world in a new way.
I gotta say, this deep dive's been a real eye-opener. I went from thinking, oh, 00038 was kind of just a boring sequence of zeros,
Right.
to realizing it's connected to this huge network of mathematical concepts.
Yeah.
And it even has implications in other fields like computer science.
That's right. It's amazing where a single question can lead you. We started with a simple sequence and ended up uncovering these connections to prime numbers, advanced math functions, even applications in computer science.
It feels like we've only just scratched the surface. Is there anything else you think our listeners should know about the OEIS or A00000038 before we wrap things up?
Well, if you're intrigued by what you've heard today, I encourage you to visit the OEIS website yourself.
Yeah.
You can search for specific sequences, browse by category, or just pick a random one and see where it takes you. It's a truly remarkable resource.
We'll be sure to include a link to the OEIS in the show notes. Any last words of wisdom for our listeners who might be feeling inspired to dive into the world of sequences?
Don't be intimidated by the math.
Yeah.
The beauty of the OEIS is that it's accessible to anyone with a curious mind.
Right.
You don't need to be a mathematician to appreciate the patterns and connections. Just start exploring and see what you discover.
That's great advice. So you wanted a deep dive on A000038.
Yeah.
Turns out it's a gateway to a whole universe of numbers and patterns.
And that's just one sequence out of millions. Each one has its own story to tell its own connections to unravel.
Wow.
The OEIS is a reminder that there's always something new to learn, always another layer to uncover.
It's like a never-ending mathematical adventure.
It is.
Thanks for taking us on this incredible journey. I think I'm going to spend the rest of my day browsing the OEIS.
That sounds like a great way to spend an afternoon happy exploring